Good day, ladies and gentlemen. I'm Sagar, your host for today's webinar. It gives me immense pleasure welcoming you all to the live webinar on the theme, Power Your Way to Industry 4.0 with SAP HANA on IBM Power Systems. This webinar is hosted by Cyber Media Research in association with IBM. For the duration of presentation, all participant lines will remain in listen-only mode. After the presentation, we'll be having a question and answer session. Your feedback is very important to us. Please submit your feedback at the end of this webinar. And now, I would like to hand over the floor to Mr. Anil Chopra, VP Research and Consulting Cyber Media Research, who will share his insights on getting ready for Industry 4.0. Thank you, and over to you, sir.
Thank you, Sagar, and good afternoon, everybody. Thank you for joining us on this webinar on powering your systems for powering your way for Industry 4.0 with SAP HANA on IBM Power Systems. Now, I will first of all start off by giving a very broad overview of some of the developments that are actually enabling Industry 4.0 and a few suggestions on what is IT's role likely to be and how they should gear up for this change that we are suddenly seeing in the manufacturing domain. So, just to look at the current situation, the state of affairs, what we know as Industry 3.0, it all has started off, and the whole idea here was to use IT to automate systems, which is why we had all the ERPs and CRM and PLM and various manufacturing automation systems that actually came in. So it was all about implementing different types of software that aim to automate different aspects and processes of a manufacturing organization. Of course, they managed to help us control, minimizing the disruptions caused by rising costs and, of raw material and components. They help us, manage things better. But of course, what's happened is that over a period of time, silos have been developed in most manufacturing companies, silos of all these applications that, are currently running in most organizations. So that is a big challenge now, because while their original intent was to, have automation in place, and as a result of that, improve productivity and enhance efficiencies in the organization, they, to some extent now, end up hindering a lot of this, and further efficiencies become more difficult and, even more challenging than, actually helping. It's actually hindering more than helping now because of so many applications. It's happening because, the customer demands are changing. There is greater demand for customization. There's reduced lead times because there is constantly changing requirements. There's no simple, straightforward requirement. There's changes. So there's a lot of disruption that has happened because of this, because the customer's demands have changed considerably. So you no longer can achieve, growth with just one single killer product anymore, unless, of course, you have a monopoly in it. So what's required is to be able to do greater customization, and that's where, the customer comes in, and understanding customer really comes in. And all this has actually increased the level of complexity in a manufacturing business, all these silos of applications and processes. Now, there is actually a, growing need to be able to achieve a further level of automation, to be able to achieve greater automation in the manufacturing processes itself, and be able to integrate the various applications so that operations can be optimized and these silos kind of go away. Now, in order to do that, there are several developments that are now taking place. And that is something, if we were to actually put those in broad level of buckets, there are actually, I would classify them as three areas. One is, of course, that, as I just talked about, shifts in consumer attitude, behavior, and expectation. They do expect a seamless experience no matter where they're actually calling you from, whether they're calling using a mobile or a landline or a personal visit or a website. Customer expectations are more seamless. They expect, for example, the same experience or level of experience that they get from apps from other industries, for instance, like a e-commerce app like an Amazon or Flipkart. They will expect a similar kind of ease of use, same kind of experience, same kind of service, which are being offered by other industries. So there's a huge change in the consumer behavior. Now, the other thing is that there are, a number of emerging technologies that are actually coming in which can help this entire automation, make it fruitful. And the third, of course, is the fact that a lot of products that are nowadays coming in, a lot of machinery that is coming in is more intelligent. There are more intelligent products. So to give you an example, now there's an entire, ecosystem that we are seeing coming in of emerging technologies and these intelligent devices, and if you really want to be able to leverage their potential, that is where the whole thing lies. How do you really do that? Now, to give you a few examples of, say, digital intelligent products, like, for example, you could have sensors inside, say, a windmill, if somebody is offering windmills, for example, manufacturing those, that can actually, have sensors that can monitor the vital components of a turbine, allowing you to retrieve information on their condition while they're operating, and actually, be able to plan ahead. Operators can then plan ahead and replace parts when they're not so functional, when it's not so windy. So actually, real-time information about the various turbines can be, sent by the various sensors in a windmill. That is one aspect which could possibly be useful for an energy, company and utilities company. The other is, of course, on the connected vehicles, side of things, where there's a lot of, IoT data that is coming in from various cars components, and that can be actually analyzed by the manufacturers to increase the reliability of their cars and offer new value-added services to the customers. At the same time, even bearings inside of trains can become smarter, and they can actually measure their vibration, temperature, torque, they can measure the speed, all of this, and they can trigger alerts and inform the operators about possible safety issues. So, and last, of course, is on the machinery inside, manufacturing plants, which can become more context-driven. There can be sensors that can enable real-time analysis of the data that those machines are operating on, and that can actually give you a context-driven maintenance. They can tell you when they require maintenance. So that way, if you look at it, a lot of digital intelligence is being built into a lot of products that are being used in the, by the manufacturing companies to create the products for the customers. So that is the change that we're really seeing over here. On the technologies front, as I said, there's an entire ecosystem of new technologies that is actually coming up, which, if used together, depending upon the requirement, can really help your journey to Industry 4.0. And this ecosystem, of course, one is the IoT bit, which is actually helping create these intelligent, building intelligence into products. Additive manufacturing or 3D printing, which is now talked about a lot, can actually help you build, print 3D products, which can be useful in prototyping or even, managing the spare parts. Simulation and visualization technologies, they have been developed so that you can actually, create products in a virtually before actually manufacturing them. And robotics, of course, is becoming really advanced, wherein machines can actually talk to each other and, manage an entire thing, operations, without human intervention, quite a bit as compared to what it used to be earlier. And of course, big data and analytics come in when there's a lot of sensor data that can come in. You need big data and analytics to be able to analyze those in real time. Cybersecurity, of course, is always important in a manufacturing company. You want to make sure that all the products that you're creating, the prototypes, the blueprints, they're secure and they're not tampered with or stolen. The whole AI and ML space, which is again connected to the robotics, to have cyber physical systems where algorithms determine how machines operate, and they're self-learning and they're able to communicate with each other and manage an operation smoothly all by themselves without much human intervention. And of course, the cloud plays a very key role over here, because all data finally has to go somewhere which has to be centrally located and accessed. So for example, data from various plants can come into one place and it can be monitored so that all the plants can be monitored from a single location. Now, the thing is that while it actually helps, to have so many technologies, and they're making a lot of changes, but how does it really affect a manufacturing setup? So that's really where the promise of Industry 4.0 comes in, and essentially the whole benefit will come when you have all these assets inside a manufacturing setup connected to each other, and you have a digital environment that uses instrumentation, IIoT, and actually you have a self-managed, self-processed, self-maintaining setup that can actually be created with the help of these technologies. Of course, you will need a digital supply chain as well that will break through all the silos that have been created by these various applications that you have in the setup, so that you have a seamless experience. There is a reduction in the supply chain, process and time, so that you can actually reduce those lead times, which are very much required. At the same time, have real-time analytics from the data that you're getting, because there's far more data that is now coming in, is likely to come in from various components, so that valuable insights can be drawn from those and important business decisions can be taken. And last, of course, as I was just mentioned, that where you have an operations center where all the data from various plants converge, and you're able to manage the operations of that from a single location. So that is in essence what an Industry 4.0 can actually promise. Now, the thing is that there are many companies globally who are actually leveraging this to some extent and already reaping the benefits. And rather than just talk about how great it is to have so many assets and all connected to each other, it's good to actually look at some examples, which I'll just quickly share through. So for example, Harley-Davidson, we've all heard of, I'm sure, build 1,700 bike variations from a single production line. And they're able to actually ship individualized bikes in 90 seconds. And because of, enabling their factories with Industry 4.0 technologies, they have cut their costs, by 7%. They have improved their margins by 19%. And they're actually reduced their time to build a bike from 21 days to 6 hours. Now, I mean, those are the kind of figures or the benefits that any manufacturing company would actually like to look at. And that is actually, one of the promises of having an Industry 4.0, move and a journey to that. The other example are the smart vending machines from companies like Coca-Cola, where, consumers are able to mix their own favorite flavors and create their own soda in seconds. Now the idea is that there are sensors in all those flavor syrups to gauge the levels of those syrups, and each machine can actually send that data and alert the supply chain when they're running low. And as a result of this, the company can also track what are the kind of trends, what are the preferences, what are the mixes that consumers are actually preferring, and they can actually develop new canned sodas. Now, this is a real live scenario that we are seeing, where various companies are adopting different types of those technologies that I really talked about to really, benefit from it. And I think many of the things that I just talked about, you can probably visualize how some of those must be actually coming in to these companies and how they're actually reaping benefit from them. Now, the question is your IT really ready for it? Is your IT infrastructure ready to handle it? Because there's a lot of differences you would have observed from these examples and from the technologies I talked about. Can you actually draw insights from the IoT data and the customer data? Or are you really currently only using IT just to primarily drive operational efficiency and for routine system maintenance? The other is to look at how much of legacy is there, and that is actually preventing integration of systems to give a seamless customer experience. And whether they need to be upgraded or replaced altogether to make sure that you can have newer technologies and software coming in that can enable an Industry 4.0 kind of a scenario. So IT's role definitely, I feel needs to change from just running and maintaining those routine applications, but to actually figure out how to disrupt the business. That is, I think, change in roles that is really required, and how can actually a company create differentiation to roll out innovative business models. And, we just saw the one example of the mixing flavors of canned sodas as one example. So different types of innovative models can actually be brought about and with, actually enhancing the user experience, which is very much required today. And having an infrastructure that is flexible enough, that is, able to allow you to innovate quickly and seamlessly without any disruption or without having to change a whole lot of things. So I think IT needs to really understand how it can actually do this and move from just keeping the lights on to truly, setup that can disrupt the business and actually help the business move forward. It should be able to bridge the gap between, operations technologies so that manufacturing can become leaner and smoother, at the same time as we move forward. So I think in order to do that, there would be a number of things that need to be done, and there would be various technologies, various infrastructure technologies that can actually come in. Now, there can be many, and some of those, I've put over here, but of course, you'll have to explore what is relevant for your business. And we notice flash storage coming up in a big way, which can actually help process data in real time, which is very much required in the IoT era where data is coming in real time. And unless and until you analyze it when it reaches, it may not make too much sense. So having that becomes handy today. A hyper-converged infrastructure that can actually simplify operations. It can actually simplify hardware and allow you to set up newer things, newer setups for testing various types of, innovations quickly. A multi-cloud strategy could be useful so that because if you're having data converging on the cloud, you want to minimize the risk of any kind of data loss or downtime. And of course, having the right platforms in place which allow you to integrate various things together. I think the role of platform becomes really, really important over here. And of course, finally, the network, which needs to be upgraded to make sure that it can handle the growth in traffic, which is coming in from all these changes that are taking place. So I think infra technologies also play a very crucial role, and become a part and parcel of an Industry 4.0 setup. In order to be able to move on this journey, in order to be able to leverage all these newer technologies. So I think for everyone, this is the time really to, gear up. And those were, I think, some of the enablers I feel are, for Industry 4.0. And I will end my presentation over here. I hope this actually helped you set the context and understand what really is required, what we are seeing happening out there. And you can actually try and work out a plan as how can, you incorporate some of these things within your own setup. And now, before I hand it over to the next speaker, who is Prashant Saxena, Technology Advisor Systems for Cloud at IBM, he's going to actually talk about how you can actually power your way up to Industry 4.0 with SAP HANA on IBM Power Systems. But before I hand it over to him, I'd request the admin to run a quick poll just to get a hang of things as to what are your thoughts about this topic. So over to you, Sagar, to run the poll. Thank you very much.
Thank you, sir. Ladies and gentlemen, this polling session is open for the next 1 minute. Request you to please submit your responses at the earliest. Thank you.
So time is up. Sagar, I would appreciate if you can share the results of the poll.
Certainly, sir. I'm furnishing the results right now. You can please view them.
Okay, so the results are there where the question was, which of these is your primary scenario? Is it a technology refresh? Is it a migration to SAP HANA? Is it an upgrade or implement SAP apps? Or is it SAP usage expansion? So the highest responses came to a technology refresh. While there are quite a few no answers, but I presume there are several people who have logged in from the audio bridge who may not have been able to participate in the poll. So with that, I would now like to hand it over to the next speaker, Prashant Saxena, who will take the things forward.
Thank you, Mr. Chopra, for setting up the platform for today's webinar. Now it's my pleasure to introduce you to the next speaker, Mr. Prashant Saxena, Technology Advisor Systems for Cloud, IBM India Private Limited, and he will share his insights on SAP HANA on IBM systems. Sir, you may begin.
Good afternoon, everybody. My name is Prashant Saxena, and I work as a technology advisor in IBM. And as rightly said by Sagar, it's a more experience sharing session rather than an education session. So it's been 3 years I'm working on as a technology advisor in IBM system, and I've been fortunate enough to participate in a lot of deals and commitments which IBM done with SAP HANA at end customer place. So this session will revolve around the experience sharing and what is my learning out of these experiences. So the objective of this presentation is divided into 3 major portions. The first portion will deal about what is SAP HANA and what it brings to the system for organization like you, and what are the benefits you can reap out of this particular software. Secondly, how IBM can collaborate and co-work with SAP HANA, and how the results can be better than anybody else, and how the overall results can improve for you if you choose IBM as a platform. Third, the overall perspective, how the overall solution can be beneficial for your business organization. Right. So to starting off, so I would like to dedicate few minutes on what is SAP HANA and how it has emerged from a very stable product of R3 to S4, which is latest offering from SAP HANA. So basically, it's been a long year. SAP has been into this ERP space, and they have working with a lot of manufacturing companies, a lot of other verticals, but eventually as they grow, they realize that there is a lot of read which is done by their customer, and now it's an era of analytics and it's an era of more read-oriented systems. How can they achieve this read-oriented system? So it is not just a one-step leap which they have done for HANA. So it is a slow and progressive development which they have done. So the first system they have developed is called the Track system, which is an OLTP search engine which they have designed for in-memory database. But they eventually realized that just building a single module, it's not sufficient to give the functionality of a very high and quick analyst who are sitting on a huge database created through their ERP. So they have done 2 major changes in their system. First of all, they have made their system a column-oriented rather than a block-level basis system. And secondly, they have moved the complete database tier to in-memory database. So earlier there were 2 functionalities which were delivered. One is called OLAP and one is OLTP, and for this different kind of modules was required. But now with SAP HANA, it is now a single functionality which is delivered by system. You can call it OLTAP system, which combines both the functionalities. And they have realized that only 15% of data which is created by an organization is more required by an organization. So they have created a dynamic clearing functionality in this their module, which is SAP HANA. That means 50% of their module will always reside in their memory, and rest other can go into the less speedy pool of hard disk or less speedy pool of disks, right? And with this emergence, they initially released this thing with their appliance approach. Appliance approach is something they have certified certain systems and incorporated the n number of RAMs, because now it is in memory system, so the every system is driven by RAM, right? So I've designed a system with n number of RAM and accordingly how much compute is delivered, and they've start giving it to the customer. It has a huge acceptance within the market, but eventually as the system utilization has grown high, they realize that the engine is very powerful, that is the application tier of SAP HANA is very powerful, but the hardware is still not able to deliver what is expected out of it. So they have done a lot of integration and reverse engineering and dicing and slicing of the problem, and they eventually realize that the prefixed, pre-decided configured appliance boxes are more consumable from the ready-to-use perspective. But for enterprise customer who want a high-end performance, these boxes are not able to fit into the bill. So what they have done in November 2015, they have opened up their architecture, and now SAP HANA is not just available in appliance approach, it is now also available in a TDI approach. So TDI approach means that you can build your hardware infrastructure for your SAP HANA given on the recommendation of SAP, and you can mix and match the hardware components. For example, you can choose the storage vendor, you can choose the server vendor, and you can design the configuration of the server as per your requirement. You don't have to go with the fixed configuration approach. And eventually, this was the scenario. Now there are two availability of architecture which is available with SAP HANA. One is called appliance approach, one is called TDI approach. But before coming to that, there is another functionality which SAP has given with SAP HANA. They have merged all the functionalities which were earlier provided in silos in a single storage pool or single memory pool. Which is, for example, if you wanted to do your analytics, the database has to be different in traditional SAP approach. But now every database has to be fetched out from a single memory pool, and because of this, the result has become very fast. That's why the read performance of system has become very, very improved. And the second change which they have done with this SAP HANA, so earlier the intelligence tier was majorly into the application tier, and database was more from the data rationalization perspective. But with this emergence of SAP HANA database, the major intelligence has moved down to the database tier, and application tier has now become more thin, and it is used more from the interface perspective. So the major calculation is now done in database tier. So earlier, whenever we have to size the earlier SAP HANA, we used to use a ratio of approximately 70-30. That means the 70% workload will go to the application tier and 30% workload will come to the database tier. But with this emergence of SAP HANA, it has just reversed. So now the majority of the brain crunching is done as the database tier. And that's why the application has become more robust, because there are a lot of, because whosoever the interface, there is a lot of possibility of hanging over there. But now the brain is there in the database, so application, any corruption, application tier will not matter to the database tier. So these are the paradigm shift they have done with the SAP HANA. So this is again an example of how database is moved. So earlier, for example, every module has to fetch their data with their own dedicated silotic approach database. For example, ERP should have their own database, CRM has to have their own database, BI should have their own database. And if somebody wants a query to run from BI, ERP wants to fetch some data from BI, they have to do intercommunication within the database. But with SAP HANA now, the database pillar is singular, so they can access to the database, and there is a reduction of hops. There is only single place where they have to go and search for the data. That's why it become very fast. So there is it's a statement which SAP HANA has given. The earlier the search used to take more than 10 minutes or 20 minutes. Now that search can be done in 10 seconds. So this is the kind of commitment and this is the kind of functionality they wanted to bring in with SAP HANA. And they have not just become analytical friendly, they have added a lot of analytical contributors also. For example, it is not just a analytics of the numbers. Now they can do predictive analytics. They are now can do text analytics. Now they can do the graph analytics, because in today's scenario, the business requirement has done a paradigm shift. There are a lot of IoT we are talking. There are a lot of unstructured file structure processing we are talking about. So SAP HANA is ready with all these kind of functionality, then they are ready to do the analytics and data performance on these kind of newer data sources. Now coming to the second portion of it, how IBM serves and how IBM serves as a OEM for SAP HANA infrastructure. So IBM has done a lot of R&D and a lot of investment in SAP HANA infrastructure. And in November 2015, right, their S4 version has released, and in the same month, IBM has certified all the servers which are available in the portfolio right now, and every server is certified for SAP HANA. So this current snapshot, which is you can view on your screen, is a snapshot from the SAP HANA directory, and it will tell you which are the supported servers. So there are a lot of questions which come from the customers sometimes and the consultant sometimes. Is your system SAP HANA certified system? So this is directly a snapshot from the SAP HANA certified system, and this only not just certified this particular system is certified. This also certifies that the complete utility of this server, it can be used for SAP HANA. So for example, a server which is mentioned over here, HA24, it is a 2-socket and 4-use system which can go up to 24 core. All the 24 cores can be utilized for SAP HANA. Whereas if you do a comparison with some x86 based server, so there is a limitation that each server cannot go to the full utilization of their box for SAP HANA. So SAP HANA on IBM Power System is basically designed to serve to the purpose where SAP HANA is an integral part of the business organization, and they are looking for a very high-performing, RAS-featured server, and their intention of IBM is to give flexibility to their customer. We don't believe in giving a system which is not flexible in nature, which is not scalable in nature. So IBM philosophy in designing a system for SAP HANA is flexibility. So that's why we have never got signed ourselves with an appliance approach. Though all the servers are certified for SAP HANA, but still we believe in giving the solution on TDI-based solution rather than appliance-based solution, because we believe in something the customer should have a visibility how much he can grow in that particular system, and secondly he can grow in that system. It should not be a dead investment in future if his requirement comes, because in today's scenario one thing is very certain, that there is uncertainty in future. You never know which application you are going to adopt. You never know what will be the number of users, what will be your growth pattern. So if there's a lot of unpredictability in systems, so we cannot do a predictable buying of an hardware. We have to go with a system which can handle your unpredictable nature of your system growth. So to add to this, IBM is the only system, I'm underlining this word, is the only system which can run multiple production instances in a single server. There is no hardware in this complete ecosystem of SAP HANA which can run multiple production instances. They can run multiple application tier. They call it multi-tenancy, but they cannot run multiple production instances. For example, if they are S4 they are running and they wanted to run with their BW, they cannot run it. But with IBM system, you can run multiple production instances. So what is the commitment of IBM system? IBM commitment for SAP HANA and SAP HANA user is that our system is first of all resilience proof. We give RAS functionality. It is the tradition which IBM is carrying forward. We just don't want to just a running system. We want a system which is reliable, which is available and which is serviceable. That's why from the reliability perspective, SAP HANA itself has quoted IBM as one of the most reliable server. So the example of this can be the world's biggest SAP HANA deployment is running on Power System. India's one of the biggest HANA deployment system is running on IBM Power Systems. So it is a proof enough to say that the IBM system are very resilient for SAP HANA system. And now coming to the performance. So IBM Power System is designed specifically, that's why I mentioned earlier that IBM has done a lot of R&D investment in designing a system which is absolute fit for SAP HANA system. So in my next slide, we'll discuss how we are built something which is specifically built for SAP HANA. Now the bottom line is that SAP HANA is in memory database, right? And what is the R&D we have done in memory? Now that becomes very imperative that memory has a very huge importance. So on this particular chart, you'll see on the left hand side, it is which RAM or DIMM slot which is used by x86 system, and on the right side, the DIMM slot which is used by IBM system. So on the physical perspective, you will see that the size of RAM of IBM system is just double in size, right? So I'll articulate why it is just double in size or why physically it looks bigger in the size. So RAM is nothing but a silicon chip which has a lot of ICs which is attached on it. So now the complete database is in memory. What is the functionality in case of the memory goes down? Is there any RAS functionality at RAM level which is available in x86 system? So answer is no. There is no RAS functionality which is available at the RAM system. To contribute to it, why we do a lot of RAIDs in a traditional hard disk or storage disk, just to give a business continuity, because data should be available at all the time. But now the data is available in RAM. Are we deploying certain kind of a strategy that data should be available in this system? In x86, unfortunately, it is not available. But in IBM RAM, you see it's double in size because we give a chip level failure to each and every DIMM module. So in the single DIMM of IBM, it can handle up to 4 chip failure. That means even the ICs goes down, it has a failover chip which has a mirrored image of that data which is available in that RAM. So it not just gives you a business continuity, it also gives you a better speed because the data can be fetched from the 2 IC chips. For example, if this DIMM slot is of 128 GB, so technically it will be 128, but physically it will be 128 into 2 because one complete set of data is there into the ICs which are not serving to the direct purpose, which are just having a mirrored image of that data. This is from the business continuity and the resilience from the in-memory system and the memory which IBM is providing. Now slightly going much deeper into what gives IBM a better performance advantage over x86. So this is apple to apple comparison. I have done a technical comparison between the contributors of SAP HANA elements which goes into the hardware. The first element is the processor itself. So IBM processor operates at 3.4 gigahertz speed, whereas Intel E7, which is the latest servers processor which is available with them, they normally operate at 2.4 gigahertz, 2.6 gigahertz. So there are a lot of flavors which are available in Intel, but none of them can go beyond 3.4 gigahertz. So at the core processing speed, data processing speed itself, the IBM has an advantage of 1 gigahertz per core. Right. Now coming, suppose there is a instruction which is there into your processor, and it is, what is the first thing our instruction does? The moment it got computed in the processor, it seeks for the data, and the first place it goes and seeks data is in the cache. On the cache perspective, IBM delivers the cache in 4 formats. One is L1, L2, L3, and L4. L4 is the only unique thing which IBM delivers. No processor company in this world delivers L4 cache. IBM delivers L1, L2, L3, and L4 cache. At each and every level, the cache size of IBM system is just 2x to the x86 cache. For example, L1 of x86 is 64 KB, IBM is 128 KB. And to add that, IBM has an L4 cache which is 128 MB. So if you do a total comparison, so x86 cache comes around some 90 odd MB cache, whereas IBM delivers some 230 MB of cache, which is 3x to 4x of the cache size itself. After cache, the processor goes and seeks data in memory, and as it's an in-memory system, as I told you, the memory importance has become very, very huge. So when the data is in memory, the data transfer speed from the processor to in-memory becomes very important. So if you see in this chart, the data transfer speed from the processor to IBM memory system is 230 GB per second. Whereas compared to x86 system, it is just 100 GB per second. So what is the use of such a high performing software when hardware cannot deliver that kind of functionality? So, and IBM runs on multiple threads. It supports 8 SMT systems, whereas Intel is still on 2 SMT systems. That means a processor which is running on 2.4 gigahertz, it is fetching data from 40 to 90 MB of cache, and it is connected to its memory system via 2-thread system. In comparison to IBM system, which is running on 3.4 gigahertz, which has a huge cache pool of 230 MB, and fetching data from the memory pool via 8 memory thread systems. So each memory thread is delivering data of 230 Gbps per second, whereas an Intel who is running on 2-thread system is delivering data on 100 GB per second. So the difference between the delivery of both the system will become very, very huge. Okay. Now coming, like IBM can give a very huge performance. But today, performance is not the only criteria which makes a choice of hardware. Can we run multiple applications? Can we run multiple things on the same physical server? Because today the problem is not just giving a compute. Today the issue is more practical in nature, that people don't have enough rack space. People wanted to do consolidation. People wanted to manage a lot of things from the single server. So it is a statement which is the power system with Power VM as the first and the only solution that can host multiple production HANA database system. It is the only system which can run multiple production database system. And so this is an example, and I have done a physical deployment how multiple production database can be delivered from one single server. So if you see on this chart, I am delivering application tier, I am delivering production tier, I am delivering non-production tier, and I am delivering multiple production tier, which is S4 and BW from the same physical hardware, which is not possible on x86 systems. First of all, x86 system cannot run application and database from the same physical server. Secondly, they cannot do non-production and production from the same system. Thirdly, they cannot do multiple production instances from a single server. So suppose if we wanted to go for a full-fledged system of BW, ERP, and multiple production instances and sandbox, that means we have to buy n number of servers to run this system. And whenever there is a growth, whenever there is a future requirement, again we have to go and add all these servers. Whereas the system which is deployed on IBM system, you just need a RAM to go. Everything is auto-configurable for you. So enough of evangelization from a hardware perspective. What is SAP's outlook on this? So this benchmark is a benchmark which is done by SAP, and it is done on their most resource-hungry S4 application, which is BW. So what they have done, they have given each vendor a record of 2 lakhs records, and they have asked to size a similar memory of 1 terabyte, right? And they have asked us to give the number of cores, what is number of cores required by each OEM to deliver those systems. How we can define the number of cores which is defined for the system? So SAP has laid down a parameter which is called TDI parameters. For example, for every 96 GB, IBM system will require 1 core. And for every 30 odd or 40 GB, x86 system will require 1 core, and it keeps varying from their model to model. But from this perspective, you see IBM has a 3x deliverance from per core perspective. So anyways, going back to this particular benchmark, they have given us a record. They have asked us to size a similar memory of 1 terabyte, and they have said it's a time-based testing, that in given time, how much percentage of records you will be able to compute. So IBM is the only one which is able to touch 100% record in the given time, whereas lot of vendors and lot of OEM which are running Intel-based servers with more number of cores, they are not able to go up to the 50% of the task to be done in the same given set of time. That's why SAP endorses very highly about IBM system. Whenever there is a requirement of huge business continuity, huge performance, we can always go with SAP words, we can always go by IBM words, that if the performance is the criteria, if the business continuity is the criteria, IBM is a very good contributor over there, especially in case of SAP S4HANA. So to summarize the complete scenario, IBM delivers the complete solution within 8 threads per core, which is 4x to the Intel as compared to Intel, because Intel still is working on 2-thread system. So as the complete process is in memory, so the data and the data transfer speed is very important, and the number of threads which are carrying those data is also become very important. So to summarize it, IBM has 4x number of threads as compared to x86. Secondly, the memory bandwidth, which is the data carrying speed. IBM has a 4x data carrying speed. IBM delivers 230 GB per second, whereas they are still flickering around 65 GB to 80 GB per second speed, which is a huge difference. The third difference is cache. IBM has a huge set of cache, which is L1, L2, L3, which is 230 MB or 224 MB of cache as compared to some 90 odd MB of cache, which is delivered by Intel. Now coming how physically these servers look like, which are certified for HANA. So as I told you, all the servers of IBM are now certified for HANA, and each server can run a hybrid solution. So SAP HANA itself is into maturing stage. They are right now available in the S4 version, which is complete application and databases on HANA. They are available on Suite on HANA, where application tier is still the R3 but the database can be HANA. So suppose if anybody is running their traditional SAP and wanted to remove their database as HANA, he can very well do it. So they are a solution which can run hybrid operating system, and there are servers which can run dedicated Linux-based systems. So, for example, ACID22L, it is a scale-out server from IBM. 8 stands for Power 8 processor. It's a 2-socket machine, and 2U is in size, and Linux, it supports Linux as a flavor. Linux flavor is for SAP HANA, Red Hat, and SUSE Linux are 2 certified flavors. And IBM right now is available for SUSE because of its better deployment and better functionality. In fact, if you see a chart of wallet share of SUSE out of Red Hat, 80 to 90% SAP HANA deployment done in world is on SUSE Linux. We are still in process of getting Red Hat certified on IBM Power System for SAP HANA. Though we are certified for Red Hat to run any other workload, but for SAP HANA we are still in process of getting it certified. And our certification ranges from the most smallest server, which is ACID22L, which can go up to 1 terabyte of memory system, to ACID E80, which can go up to 16 terabyte of HANA system in a single server. So as I was mentioning, the world's biggest deployment of SAP HANA, which is some 88 terabyte HANA system, is running on E80 system. It is running on multiple E80 systems. And now coming from because IBM is one OEM which believes in giving the complete suite of solution to any application. So all the storage offering of IBM are certified for SAP HANA, starting from the smallest SAN-based storage of V series to the highest level and the most quickest flash-based system. Every storage product which is available on the portfolio is SAP HANA certified. So recently there is a question which pop up into here: is SAP HANA can run on AIX system? So SAP by default has certified their application on two flavors of operating system, which is Linux of Red Hat and SUSE. So you can run your traditional HANA, traditional SAP on AIX, and it can coexist with your HANA database system. That means your application tier is on AIX and your database tier is on HANA. It can coexist, but unfortunately HANA as an application is not available on AIX. So it is SAP HANA which has made a choice. They wanted to go with only with Linux as a platform. They have not chosen Windows. They have not chosen any of the Unix flavor to run SAP HANA application. So now coming to the question, SAP HANA is fine, the speed is fine, hardware is also fine, but what about the business continuity functionality of SAP HANA? Because our traditional database like Oracle is very good with ODG and RAC kind of system. What kind of functionality of failover available in SAP HANA? So SAP addresses almost all kind of business continuity functionality which is delivered by the traditional database system. It supports storage-based replication. It supports active-passive cluster, and it also supports a shadow approach, which is additional functionality which is not available in the traditional system. A shadow approach is called, or you can say system replication approach, is something when production can fail over on non-production. Right? In case of failure, people have realized that their non-production is not into the use. So production can mount to the non-production resources, and at that time the non-production can go up to very minimum utilization of, for example, 10% or 1% of utilization. By this, a customer can configure their system for optimum utilization. They don't have to park a physical resource just for failover. So this is one of the approach, and this is an absolutely automated approach which is contributed by two of the functionality. One is it is done by HANA application, and one is it is clubbed with SUSE cluster. And by this, combining these two technologies, we can make it fully automated system for failover perspective. And these are the few customers which are there. These are not the complete list of customers which are available on IBM system and running SAP HANA. These are dedicatedly SAP HANA customer, and almost all of them are S4 customer. So because SAP with S4, IBM Power System becomes generally available for the system, and there are a lot of customers we have tried and chosen almost from all the vertical. For example, pharmaceutical vertical we have tried and chosen, and we also try to create a mix of their size. Few are big customer, few are mid-size customer, few are like a mid-size customer, but everybody is running on SAP HANA on their power systems. So my request is to the followers are, SAP HANA has become a very evident choice because of the promises they have made, the promises of speed, promises of faster analytics. But these promises can be only delivered when we give him the right set of physical tools, which is a very reliable hardware, a very quick hardware, and which can promise you business continuity. Right? On these elements, IBM has done a lot of investment. It has done a lot of investment in their memory. It has done a lot of investment in cache, which is not available in any of the other fellow competitor or OEM. It has done a lot of investment in application fine-tuning. It has done a lot of investment in doing the implementation at the customer place. So if IBM becomes a choice, IBM lets people will go and do the deployment. It is not done by the engineers or the mundane engineers. It will be done by the IBM lab people. So this is the kind of investment, and this is the kind of commitment we wanted to bring for the people who are evaluating SAP HANA. Because the complete mantra of this evolution is based on analytics, it is based on speed, and it is based on faster go-to-market. And IBM wanted to be partner with you in this complete mantra. So with this, I wanted to end this presentation, and I wanted to invest more time on the question and answer rather than giving just a monologue about how IBM is good. So I would like to answer the questions if you have. Thank you from my side. Thank you, Sagar.
Thank you, sir. So ladies and gentlemen, at this time, should you wish to ask any questions, you may please press 0 and then 1 for any audio questions. Also, to ask any questions over the web, you may use the chat facility on the right-hand side of your screen. Please post your questions to all panelists. Thank you. Once again, participants, to ask any questions, you may please post your questions to all panelists on WebEx. Also, to ask any audio questions, you may please press 0 and then 1.
So, Prashant, there is a question about, application integration. Where, you showed that so many different applications can connect to a single HANA instance running on Power. So is it only SAP applications, or which all applications can be supported?
So SAP HANA is a dedicated database which is built for SAP applications. So it does not support any other application from SAP rather than SAP applications.
Okay. So now, so Gopala Krishna wants to know, why isn't there any comparison against IBM iSeries?
Why there is no comparison between IBM iSeries? So SAP's roadmap is they have declared a blog which says that after 2023 they are going to withdraw their support from all other databases. So IBM iSeries works on DB2 as a database. So in the roadmap, everything will be withdrawn from any other platform rather than HANA. So iSeries is still working for traditional SAP, is still working, you can run it on iSeries. But for application where you see your future is HANA, the choice has to be one of the hardware, not iSeries.
Okay. And Sandeep Port wants to know, as it is in memory, so can we increase the RAM in production VM without any downtime?
So it depends on which hardware you choose. So if you choose enterprise class of hardware, because there are more racks of functionality which are built into it, in enterprise class of server you can increase that. But in a scale out, there has to be a small downtime or a small reboot which we have to do.
Okay. And there is a question by Binu Lakshmanan that in India, SAP HEC is with Control S. Why not with IBM? And why not IBM?
So so SAP HEC is a delivery which is led by SAP, but SAP HANA is available on IBM Software Cloud also. It is not HEC, but if you want to deploy SAP HANA on cloud, you can choose software as a service provider. So HEC is a branded service which is given by SAP HANA. Which is they have done a tie-up in backend with controllers. I hope I have answered the question.
Okay. Okay, so why is IBM recommending C4 SAP in India rather than Power Series as a TDI? By Binu Lakshmanan.
So I mean the question, I didn't get the question completely. So IBM is recommending S4. S4 is a variant of SAP. So IBM is not recommending or evangelizing any of the version of SAP HANA. So we are saying that the latest version is S4 HANA. We are S4 HANA certified. We are also SAP traditional SAP HANA certified. On the same power system, you can run your S4, you can run your R3, and if you want to continue with the traditional approach of R3 mixed with any other database, we can still continue it. But the SAP's roadmap is for going for S4, so that's why we are evangelizing on that we are S4 ready. But we leave it to the customer what is their choice of application and database suite. We are available with all the possible flavors of SAP.
Okay, and again a question back again from Gopala Krishna, that based on what you just answered earlier, is it confirmed that IBM iSeries is not available for HANA-based DB?
Yes, IBM iSeries is not available for HANA-based DB.
Okay. So there is a question from Swapan Kumar Banerjee.
But
yeah.
Here is one thing. If somebody is running IBM iSeries on IBM server, Power 8 server, for example, asset 2.4, so he can run iSeries in a silo and SAP HANA on the same server. But iSeries does not support HANA is one fact, but IBM platform support SAP HANA, and both can coexist at the same time.
Okay. Question from Swapan Kumar Banerjee that we are using SAP ECC6 for 7 years and the current database size is 450 GB. It is incremental. It is incremental at 65 GB a year, and about 175 users are there in SAP. So what will be the hardware sizing in terms of memory, HDD, CPU for migrating to S4 HANA?
Okay. So there is a very easy tool which is available, which is called SAP Quick Sizer. And in this, you have to just fill this data, which is you have mentioned over here, right? And it will give you two output. One output is what will be your HANA size and what will be your SAP's requirement. And you can choose for the number of years you wanted to do the calculation. So this is the formal way of doing the calculation. But if you want to do a just thumb rule of calculation, just do this math. Whatever the data is coming for your 5 year, SAP HANA promises you 1/4 to 1/7 level of compression. So suppose your data size today is coming as 1 terabyte, you can easily go up to 256 data consider as 256 data for your HANA size, and accordingly you can size your hardware, because SAP HANA has inbuilt functionality of dynamic tiering. So 256 is your dynamic tier, and it will never exceed that particular thing.
Okay. And Devashish Banerjee wants to know what would be the RAM requirement if you have 500 users and DB size is 700 GB.
So that's I answered. The formal way is to do an exact quick sizing. The quick way is 700 GB. I take it as a 1 terabyte approximately. So I do a compression of which SAP HANA suggests, which is 1/4, which is the minimum level of compression they suggest, 256 GB of HANA size.
I see. Okay. Sagar, are there any questions coming in from the audio bridge? Maybe we could answer some of them now.
Yes, sir. We have a few indications on the audio. First one is from Mr. Satish. The line is unmuted.
Yeah. Good evening. My name is Satish.
Good evening, sir.
We are on Power 8 system.
Okay.
Basically running our production development and BW systems and EP systems and AI systems.
Yeah.
Recently we have implemented DR, and it is on the storage is on Hitachi.
Okay.
In terms of what I want to understand is now we have IBM Unix for our ERP and dealer management solutions, and we have various flavors of Unix. Like the CRM, we run on HP Unix, and the x86 for the APOs and all those things. Now, if this is our scenario, how do you think we can move to HANA?
Okay. First of all, the HP. If I understand the question, so there is a solution which is you are running the solution in a hybrid environment of Unix. Few tiers are on IBM, few tiers are on HP Unix, and few tiers here and there, and the storage is Hitachi storage. Am I correct?
Yes.
Okay. Yes. So first of all, IBM is the only SAP HANA certified RAS-based processor. No other processor which is a RAS-based processor is SAP HANA certified. So your IT enemy absolutely goes out of picture over here, right? If you wanted to do a HANA journey, but you can continue on IBM Power 8 system. If you wanted to continue AIX mixed with SAP HANA, you can continue that. If you want to run SAP, so say on this particular hardware, you can still do it. You don't have to do any investment on hardware perspective. The only investment you have to do is you have to buy a SUSE Linux, which is a socket-based license, and you have to buy the required number of RAMs. I'm assuming in traditional SAP the RAM size will be slightly on the lesser side, and in HANA side it will be on the more side, right? So in IBM Power 8, there is an investment protection. You can continue, you can use it for SAP HANA. Unfortunately, for HP based Itanium system, it is not SAP HANA certified. And regarding your storage, you have to run that query with Hitachi whether that particular storage is SAP HANA certified, because as I am aware, all the storage of Hitachi are not HANA certified, but still that query can be best answered by Hitachi.
So that means we cannot immediately move to this solution.
So you can immediately move to this solution on IBM system, but this is actually a very broad question you are asking, because we need to do a proper sizing of your workload which will come into SAP HANA. Then we see what are the resources available on IBM Power 8 system. So if it is available, you can immediately move ahead. But if it will be less in number, then we have to do a proper. Then we might have to do an investment of buying one server on another server. But yes, you can initiate this transition immediately, as you have already have IBM system in place or in house with you.
Okay.
Okay, Sagar, we can maybe take one more question from the audio bridge if there is any.
Yes, sir. We have one more indication from Mr. Ganesh. The line is unmuted.
Yeah, thanks. This is Ganesh.
Good evening, sir.
Yeah, good evening. The presentation which you shared was a comparison between Intel and Power, and Power outmarks Intel in terms of performance, and that's an excellent part. But the deciding factor in market, in today's market, is the price, the costing. So would there be some kind of an competitive rates that IBM Power 8 can give in terms of Intel which they offer? So any comparison that you can share?
I mean, first of all, it's a very good question which is asked, which makes a lot of practical sense, right? So first of all, sir, if you see how do people compare a pricing? Normally people compare pricing, I wanted to buy a server, what is the cost of your one server, right? But the actual scenario of costing in case of HANA is, what is the total cost of designing this solution and what is the hardware which is required as compared to what is the hardware which will be required by Intel. Trust me, we have done a lot of TCO comparison. A HANA solution which is designed for Intel and a HANA solution which is designed for IBM almost come at par. Sometimes we give a better cost, sometimes they give a better cost, but because the number of resources which are available in Intel is 3x to ours, our per core pricing might be bigger than there, but they require more number of resources, physical resources. They require more number of physical resources than us. So that's why if the true comparison can be done, you share us a workload, we design a solution, and you share the same workload with Intel. This design the solution, and what is the total cost of ownership of these two solutions? I think IBM is very competitive in the SAP HANA workspace. And I mean, just to share on this perspective, we become GA in November 2015, and today we have just covered 2 years. And in India itself, we have captured 60 odd S4 customers, which is a huge boost, because we were not there for the time immemorial, whereas Intel was delivering this SAP HANA system since the inception of S4 HANA, as the inception of SAP HANA. So there is a lot of acceptance because we give a performance at the good price.
Okay, yeah. Thanks for this information.
Yeah.
Okay, so I have a question from Debashish Banerjee which says we have procured IBM Power 8 systems last year. Now, how to go for SAP HANA migration? We are at ECC 6 with Oracle DB. Will AIX run on HANA?
Okay. So first of all, you have to decide what kind of strategy you want to adopt. If you wanted to go for Suite on HANA, you can run your application tier still on AIX. you have to replace your Oracle and it's a rip and replace the strategy. You can replace your Oracle database and use SUSE as an operating system in the same physical server, and you can start using HANA as a database tier. So this is a strategy for Suite on HANA. Strategy for S4. In S4, the application tier and the database tier both has to be changed, right? So still you have to remove all your AIX because S4 does not support AIX as an operating system. It only supports Linux as a flavor. You have to replace your AIX. Physical server will remain the same. You have to buy SUSE licenses, which is a socket-based licenses, and you can start using this the same physical server for your SAP HANA S4.
Okay. I guess that answers the second question the same person had about whether they need to buy SUSE for HANA, if yes, and how IBM will help.
So you can buy SUSE from SUSE itself, you can buy SUSE from IBM itself, but IBM SUSE, we give a very competitive price, and secondly, if you buy it from IBM, you get a 2-layer of support. One, the L1 will be given by IBM and L2 will be given by SUSE. So I always, whenever my customer also, I say buy it from the single OEM and make it a single point of contact for all your troubleshooting. But the choice is open. You can buy it from SUSE and run it on IBM system also.
Okay. Thanks. Are there any other questions from the audio bridge, Sagar?
No, so no further indications on the audio.
All right. So with that, we will wrap up this session and maybe wait for maybe 10 seconds to see if there is any further questions anybody wants to ask. If yes, we will answer. Otherwise, we will go ahead and end today's webinar.
Certainly. I will make one more announcement, sir. Participants, you may please press 0 and 1 to ask any audio questions, or you may use the chat facility to ask any questions over WebEx. No further indications, sir.
Okay, so if there are no more questions, then we will call it the day. Thank you, Prashant. Thank you for that session and answering all the questions. Thank you, delegates, for taking time to join us on this call, and I hope you found it useful. For those, some of the people I noticed, one person was not able to join in, was having some trouble connecting. So we will be sharing a recording of this webinar later on with all the participants, so that you can go through it again, and if you have any further questions after that, please feel free to ask and send them to us. So okay. Thank you very much. We will conclude and end the session now. Over to you, Sagar.
I thank both the speakers for addressing the session today. All participants, feedback form will shortly appear on your screen. Please submit your responses. Hope you have spent useful time with us. On behalf of IBM and CMR, we conclude this conference. Thank you, and you may all disconnect.